The reason air conditioners listed with a maximum fuse size nameplate cannot be protected by circuit breakers stems from fundamental operational differences between fuses and circuit breakers. Fuses are overcurrent protective devices that operate on the principle of melting a current-carrying element when the current exceeds a predetermined value. This melting severs the circuit path, interrupting the flow of electricity. Circuit breakers, conversely, employ a mechanical mechanism to trip open the circuit upon detecting an overcurrent condition. This mechanism typically involves a bimetallic strip or a magnetic coil that responds to the increased current, causing the breaker to trip. The crucial distinction lies in their response to transient overcurrents, particularly those encountered during motor starting. Air conditioning units contain motors which inherently draw a significantly higher current during startup than during normal operation. This inrush current, also known as locked rotor current, can be several times the motor's full load current. If an air conditioner is protected solely by a fuse, the fuse is selected with an ampacity rating that allows it to withstand the brief inrush current without blowing, yet still provide protection against sustained overloads and short circuits. The fuse's time current characteristic, specifically its inverse time characteristic, is vital here. This characteristic dictates that the fuse will tolerate higher currents for shorter durations and will trip faster at higher overcurrent levels. However, if a standard circuit breaker is used, the inrush current can cause the breaker to trip. While the breaker can be reset, this repeated tripping is problematic. Firstly, it is a nuisance, interrupting the operation of the air conditioner. Secondly, and more importantly, frequent tripping can damage the circuit breaker's internal mechanism, potentially leading to premature failure or a reduction in its ability to accurately and reliably protect the circuit. Air conditioner manufacturers obtain listings from qualified electrical testing laboratories, such as Underwriters Laboratories, to certify that their products meet specific safety standards. These listings often include specific instructions regarding overcurrent protection, including the maximum fuse size. When a listing specifies a maximum fuse size, it signifies that the air conditioner's design and testing were performed with fuse protection in mind. The equipment's susceptibility to nuisance tripping and the breaker's potential for damage under repeated tripping conditions are factors that influence this listing. Furthermore, the listing might consider the motor's thermal protection characteristics and how they coordinate with the fuse's time current characteristic. In other words, the fuse is chosen to protect both the motor and the air conditioner's components from overheating and damage, while still allowing the motor to start. The National Electrical Code, or NEC, provides guidelines for electrical installations, including the selection and installation of overcurrent protective devices. NEC Section 430 covers the protection of motors and motor circuits, providing detailed requirements for fuse and circuit breaker size. However, the NEC also recognizes that product listings and labeling take precedence. Therefore, if an air conditioner's nameplate specifies a maximum fuse size, that requirement must be followed, regardless of what the general motor protection rules in NEC Section 430 might suggest. In summary, air conditioners with a maximum fuse size listing require fuse protection due to the operational characteristics of fuses and circuit breakers, the inrush current of motors, the potential for nuisance tripping and breaker damage, and the specific requirements of product listings. The fuse is chosen to provide adequate protection while allowing the motor to start reliably, while the use of a circuit breaker could lead to operational problems and equipment damage. This requirement is not directly related to motor type in a categorical sense, such as induction versus synchronous motors, but rather to the motor's inrush current characteristics and the overall design of the air conditioning unit and its protection scheme. It's important to consult the air conditioner's nameplate and the NEC to ensure proper overcurrent protection is provided. Ignoring these requirements can lead to equipment damage, fire hazards, and violations of electrical codes. Furthermore, specific types of fuses, such as time delay fuses or dual-element fuses, are often recommended for motor protection because they are designed to withstand the inrush current without opening. These fuses have a built-in time delay that allows them to tolerate the temporary overcurrent condition during motor starting. The selection of the correct fuse type and size is critical for ensuring reliable and safe operation of the air conditioner. In addition to the fuse's time current characteristic, its interrupting rating is also an important consideration. The interrupting rating is the maximum fault current that the fuse can safely interrupt without rupturing or causing damage to the surrounding equipment. The interrupting rating must be high enough to handle the available fault current at the air conditioner's location. The available fault current is the amount of current that would flow in the event of a short circuit. This current is determined by the impedance of the electrical system and the voltage at the point of the fault. Electrical engineers typically perform a short circuit study to determine the available fault current at various points in the electrical system. This study helps ensure that all overcurrent protective devices have adequate interrupting ratings. When selecting a circuit breaker for motor protection, it is important to choose a breaker that is specifically designed for motor starting applications. These breakers, often referred to as motor circuit protectors, or MCPs, have a higher instantaneous trip setting than standard circuit breakers. The instantaneous trip setting is the level of current at which the breaker will trip immediately, without any intentional delay. A higher instantaneous trip setting allows the breaker to tolerate the motor's inrush current without tripping unnecessarily. However, it is important to note that the air conditioner's listing takes precedence over the general requirements for motor protection. If the air conditioner's nameplate specifies a maximum fuse size, then a fuse must be used, even if a motor circuit protector would otherwise be permitted. The use of fuses for motor protection is often preferred in applications where reliability is critical. Fuses are generally considered to be more reliable than circuit breakers because they have fewer moving parts and are less susceptible to mechanical failure. Additionally, fuses are inherently current limiting, meaning that they can limit the amount of fault current that flows through the circuit. This current limiting ability can help reduce the damage caused by short circuits. The NEC provides detailed requirements for the installation of fuses and circuit breakers. These requirements cover topics such as enclosure requirements, conductor sizing, and overcurrent protection device ratings. It is important to follow these requirements carefully to ensure a safe and reliable electrical installation. In addition to the NEC, local electrical codes may also have specific requirements for the installation of air conditioners and other electrical equipment. It is important to consult with a qualified electrician to ensure that the installation complies with all applicable codes. When replacing a fuse in an air conditioner, it is important to use the correct type and size of fuse. Using the wrong fuse can damage the air conditioner or create a fire hazard. The fuse type and size are typically indicated on the air conditioner's nameplate or in the manufacturer's instructions. It is also important to ensure that the fuse is properly installed in the fuse holder. A loose or corroded fuse can cause overheating and premature failure. Regular maintenance of air conditioning equipment is essential for ensuring safe and reliable operation. This maintenance should include periodic inspection of the fuses and circuit breakers, as well as cleaning of the air conditioner's coils and filters. A qualified HVAC technician can perform this maintenance. In conclusion, the use of fuses for air conditioner protection is often required by product listings due to the inherent characteristics of fuses and circuit breakers, the inrush current of motors, and the need to protect both the motor and the air conditioner's components from damage. The NEC provides general guidelines for motor protection, but product listings take precedence. It is important to consult the air conditioner's nameplate and the NEC to ensure proper overcurrent protection is provided. The information presented here is for general educational purposes only and should not be considered a substitute for professional electrical engineering advice. Always consult with a qualified electrician for specific electrical design and installation questions. The selection and application of overcurrent protective devices is a complex topic that requires a thorough understanding of electrical codes, product listings, and the characteristics of the equipment being protected. Firstly, consider the specific requirements outlined in the NEC, specifically Article 430 concerning motors, motor circuits, and controllers. Secondly, always prioritize the manufacturer's specifications and listings for the air conditioning unit, which often dictate the type and size of overcurrent protection required. Thirdly, understand the difference between inverse time circuit breakers and instantaneous strip circuit breakers, also known as motor circuit protectors. Fourthly, the available short-circuit current at the point of installation must be determined to ensure the selected fuse or circuit breaker has adequate interrupting capacity. Fifthly, the ambient temperature surrounding the overcurrent protection device must be considered, as high temperatures can affect the device's performance. Sixthly, proper coordination between the overcurrent protection device and other components in the circuit, such as motor overload relays, is essential for ensuring comprehensive protection. Seventhly, regular inspection and testing of overcurrent protection devices are crucial for verifying their continued functionality. Eighthly, any modifications or changes to the electrical system should be performed by a qualified electrician and must comply with all applicable codes and standards. Ninthly, proper documentation of the overcurrent protection scheme, including fuse sizes and circuit breaker settings, is important for future reference and troubleshooting. Tenthly, ongoing training and education on electrical safety and overcurrent protection are essential for all personnel working with electrical equipment.